Hey guys, welcome to the first Math Heads 101 video. We're going to be discussing limits. And then we're going to be doing different types of limit problems. So a limit is what happens when you approach something. So here's our graph. Kind of a horizontal graph or tilted, whatever. Okay, this is your x-axis. This is your f of x axis, or you might be familiar with y. We could either say that, or it's your y-axis, depending on what you're familiar with. I just get used to both notations. So if I have a function, and a function is just, you give me an x value, I'll give you the value of the function. So different graphs can graph different types of functions, but a function is just, you give me an input, I give you an output. So in this case, we can graph the inputs on this horizontal line, and the outputs that we are able to graph are all real numbers that we can graph on this. So if I have this graph, and I'm just saying that f of x, the value of the function looks like this, and for at this point, we'll call that 2, we'll say that's 4. So it goes along this smooth curve, and it goes along this smooth curve, and just the value of this function, the value of the function at this point happens to not be along that curve. Okay, that's possible. It's just a function. You give me an input, I give you an output, and it just so happens that all the other outputs are next to each other, but they don't have to be. So now we're going to say, what is the limit? And I'll also say that this point over here is 3. So the limit, okay, so first off, we're going to get used to notation. So f of 2, that means the value of the function at 2 is equal to 4. But the limit, as x approaches 2, is of f of x is equal to 3. So what I'm just saying is, the limit is not equal to the value of the function. The limit is equal to what the value of the function is approaching. So you're going closer and closer to 3 in this way, closer and closer to 3 this way. But it's not always going to be like that. Let's say we have, I'll give you, we'll say f of x equals 1 over x. So let's try to understand what that graph looks like. You divide something, the bigger the number you divide it by, the smaller it gets. So it's going to go look like that, and it's never going to actually hit 0. And this is going to go up like that. Okay, now, if you divide something by a negative number, it's going to come negative, but it's still going to get smaller and smaller. So it's going to look like that. And if you don't understand why the graph looks like this, just think about it. Okay? So maybe pause the video, try to understand it. Okay. So now we're going to say, what is f of 0? F of 0 is not defined. Just because you can't divide by 0, that is not defined. There's no defined way. I'm going to divide by 0. Now what is the limit as x goes to 0 of f of x? Well, let's take a look. So let's go closer and closer to 0 here. So here I have some number, bigger number, bigger number, bigger number, bigger number. So maybe it's infinity. Okay, let's check. Let's just be careful. Oh, wait. Oh, it's going to negative infinity from this side. So it's not approaching any number at all. So you're going to say the limit equals doesn't exist, I guess. That's not really a good way to put it, but the limit doesn't exist, okay? But if I were to say approaching 0 from the negative side, then it's going to be negative infinity. If I say approaching 0 from the positive side, it's going to be positive infinity. So that's limits. You need limits if you want to use infinity, because infinity is not a number, but infinity is something you can approach. You needed limits if you want to see what happens as you get closer to something. You need limits if you want something that's very small but not equal to 0. And that's pretty much it for limits. Most limit problems aren't visual, they'll give you a problem. So let's go over different limit problems and how to solve them. So we have the limit as x goes to 0. No, we'll say as x goes to infinity because we haven't used infinity yet. And I think it's always fun to use infinity in math. I really hope I wasn't standing in front of my work the whole time. Okay, limit as x goes to infinity of x cubed, 3x cubed over 2x cubed. Well, you might say, hey, that's definitely going to be equal to infinity because I'm going to have a huge number and this is going to be dividing by a smaller number. But x cubed, and this x cubed are going to infinity just as fast. So don't worry about that. So it's equal to 3 over 2. Similarly, if I were to say the limit as x goes to 0 of 3x over 2x, that's not defined because 2, you plug in 0. The first thing you want to do is see if you can plug it in. Because if you can plug it in, that means that it's smooth and it'll work. If you can't plug it in, that means that there's a problem there, and that's why they give you a limit problem. So usually it won't work, but sometimes if your teacher's dumb, it will. Okay, so this, I don't know exactly what it's going to look like. It's going to be some graph, and it's not defined at 0 because you can't define. Okay, so there's a hole at 0. Okay, but you know there's a hole at 0, but the thing it's approaching, this doesn't matter, so you can just take those at, and it's going to be equal to 3 over 2. So if you can factor out the x, that's one way to solve it. Another way to solve it is you see which is going to approaching a value faster, the top or the bottom. That's called L'Hopital's rule, but you can't understand that until you understand derivatives, and you can't understand derivatives until you understand other kinds of limits. So kind of dumb, you're using limits to prove something which you can use to prove limits, but you know, that's math. Okay, let me see if there's anything else. Not really. That's it for limits. Thank you for watching Math Heads 101.